Okay, we're going to summarize the one spin Zeeman Hamiltonian, which is the interaction of a single spin. In this case, we're going to make it a spin 1/2 for simplicity with a main magnetic field, B0. And the operator that represents this is the z component of the nuclear spin angular momentum, Iz, the gyromagnetic ratio, which is intrinsic for the nuclei of interest, and the magnetic field that it's in. This Hamiltonian, when you take its one spin Hamiltonian, operate it on the wave function for that, gives you the gyromagnetic ratio, the magnetic field back out. There's the operator operating on this. Gives you a half Iz operating on it. We can represent that in frequency units by the Larmor equation. So, if we want to represent the Hamiltonian one spin, we can do it two ways in frequency units in radians per second, or we can do it in hertz by dividing by 2 pi. So this would be in units of hertz, and this would be in units of radians per second. So to summarize this, if we think of what the wave function is, and then we can have the eigenvalues for that we just looked at, we just solved, and we can represent those in energy units, in frequency units of radians per second, or in frequency units of hertz. So we have in general 2 for a spin 1/2 system. It can be plus or minus 1/2, representing the wave function, plus a half, which we often call alpha, or the wave function for minus a half, which we often call beta. In energy units, 1/2 h bar gamma b0, or plus 1/2 h bar gamma b0. In frequency units, this is 1/2 omega, or minus 1/2 omega, and then finally. So that summarizes our one spin where I is a half system.